In this question, I'm going to go through what you should have covered in the mathematical models chapter. So it's about quadratic equations. This is a past paper question from 2014, so November 2014, and it's a paper 1 question. This is question 14 from that paper. So we have a question dealing with quadratics, and it's already telling you that the axis of symmetry of the graph has the equation x equals negative a half. So remember that your quadratic equations either have the form of this and this, and they're always symmetric at the vertex. So you have this symmetric line that goes through. So it's actually a vertical line, and this vertical line has an equation, and this is how the equation looks like. It's usually x equals to whatever it's positioned at. So draw the axis of symmetry in the following axes. You could draw it as a dotted line if you want to. You could also draw it as a straight line. But as long as you indicate it through and not a point. So it's a line, it's an actual line, so you have to go... let's go with dotted, and just going to go with the red just so that it stands out. So negative a half will be here. So notice that the graph is divided into halves. And we could do this, so it should be good enough. You could indicate it as well if you want to, just for the sake of clarity. So this is x equals negative a half. Now, the graph of the quadratic function, so we're still talking about the same function, intersects the x-axis at the point n to 0. There's a second point m at which the graph of the quadratic intersects the x-axis. So obviously it's a quadratic function. It has at most 2 intersections. They've given us one, which means the other, and they've told us that the other exists as well. And they want us to mark that point m. So we know the first point of intersection will be here. So you need to clearly mark it using n. They've given you a labeling, and this is what you have to use. You could do a quadratic equation here, quite complicated solution. This is actually quite simple. It's a 1-mark question. Because it's symmetrical, this is the property of quadratic graph. Everything's symmetrical. So the other x-intersect will be at the exact same symmetry point, just the other way. So if you notice, we moved 1, 2.5 points. So we're going to do the same thing here. So this is a half, and then 1, 2, so 2.5. So this is our second point of intersection. So this will be m. So remember, quadratics are symmetric about the axis of symmetry, hence the name. Therefore, it will be equally there. So don't mess this up as a 1-mark question, because it's quite easy to calculate, and it's you might get confused with the scale that they've used here of a half. So this is m. Now the graph of the function has the equation y equals x squared plus bx plus c. So they're telling us the coefficient of x squared is actually 1. Find the value of b and the value of c. Draw the graph of the function on the axes. We actually don't need part I to actually do II, so I'm just going to do II for now, just to be quick. What you will need though is the vertex, so you could actually do it from there, but let's do it in order. So part I asks you to write the equation. So because you have, there are many methods to do this, but because you have 2 and -3 as solutions, it means that you can write this in a factorized form, but remember you need to swap the signs. And once you've written in such a way, you can just expand the bracket. So x times x times this, and similarly here. There, so you end up with x squared, x times +3, so 3x, negative 2 times x, and negative 2x, and then negative 2 times positive 3, so that's a negative 6. And this simplifies to plus x minus 6, which means that b is equal to 1 and c is equal to negative 6. Now to find the vertex, the minimum point, we know this has a coefficient of a positive 1, so the graph is going to look something like this. Because of the coefficient of x squared, but we need to know where's the minimum point. Well, we know that the x coordinate of this will be negative 1 over 2. So we just need to know where the y coordinate will be. There are many methods to find this, but we can just substitute in our original. So I'm going to substitute negative 1 over 2. Plus negative 1 over 2 minus 6. So this will be 1 over 4 minus 1 over 2 minus 6. And that should give you a decimal number. So we have a negative 6.25, which is the same as negative 25 over 4. So negative 6.25, so somewhere quite close to negative 6, so somewhere here. And then you need to have a smooth curve to be able to get the points. It has to be a smooth curve. It has to go through your x-intercepts, and it has to go through the vertex. So we have, this is quite hard to draw on a tablet, so obviously it should be much smoother in an exam. Okay. So make sure it's a smooth line. You get only 1 mark if the curve is not smooth, or if it's not concave up. So if you've accidentally done this concave down. I just move this out. So this is it. That's how you do this question. Quite a simple one. Just remember these facts. It just expects you to know all of these facts throughout.